Hi, welcome to How to Repair. In this video I'm going to be teaching you all about the heating circuit on your Hoover or Candy tumble dryer or any associated make to the Candy group. On the normal vented tumble dryers and the condenser tumble dryers, they have a heating system which is very similar. Normally they have one or two thermostats on the front of the machine and one or two thermostats on the rear of the machine. This is a vented tumble dryer. This tumble dryer has two thermostats on top of the heating unit at the rear of the machine. It also has an NTC sensor which controls the temperature and gives the circuit board the correct information of what the temperature is inside the machine, and it's also got a airflow thermostat at the front which can be tested. All these thermostats can be tested, also the heating element can be tested. But on occasions you may have a circuit board fault, and at the end of the video I will also show you the fault that was with this machine and how to repair the circuit board as well. But let's start straight away. Now I'm going to speed up the video. Simple reason being is at some point I have to take the whole front of this machine off, and rather than making it a long video I'm just going to fast forward the whole section so you can see roughly how it comes apart, and you can see more detail on this on the other Hoover and Candy videos on how the front of the machine comes off. First thing you should always do before doing any work on any of the appliances, make sure you disconnect it from the electricity supply. We're going to turn this machine round to gain access to the heater. To gain access to the heater you're going to need to remove the rear cover. Once you've undone the screws, remove the cover. This now gives you access to the two thermostats on top of the heater. Right, basically we have two thermostats at the top here. I've just taken off the looping wire, so I'm going to be able to test across this one and this one. We should have continuity on both of these. So I've got the meter set to continuity. That's good. And that's good. Next we're going to disconnect the heater and inspect it for any damage, and also do a check on the heater itself. Right, we can carefully pull the wires. Not on all occasions will you be able to get this out. If it does come off or any of the wires pop back in, really the only chance you've got is to take the front of the machine off. So be very careful and make sure you photograph any of the wiring before disconnecting it. Right, I've managed to get all the wires through. Now I'm just going to show you a little technique so accidents do not happen. These are notorious for going back through, so what I have a tendency of doing is just putting a cable tie or a piece of string around them, and that will stop them falling back through. And make sure you take a picture of the wiring. We're very lucky on this one, it's all colour coordinated. So we've got white to white, red to red, black to black, yellow to yellow. So we'll disconnect all these. And now we'll undo the heater at the top. Now the heater just comes away. The heater has a high and low side to it. So in other words, the element is two parts. Now the black and yellow wire actually go to the same terminal on the neutral side of the element. The white and red are the high and low parts of the element. So we'll do a check across these three fields. The first field we have continuity. The black and the yellow nothing, and the other field we have continuity. This element is good. So we'll just connect this back up and then we'll do some tests on the forward thermostat. To try and help up in the speed of this video, I'll cut now to the taking the front off and we won't film putting the cover back on here or connecting the wiring up. Right, we've checked the heater on the rear with the two thermostats. Now I'm going to fast forward the video and we're going to take the front of the machine off so we can check the NTC sensor and the thermostat on the front. Two screws remove the lid. Wood may swell, may become sticky. Now there are two wires inside holding the door. This is a micro switch, two wires for the on-off on the door. Doesn't matter which way they go round. Here we have the thermostat I was on about, and this is the NTC sensor. They're straightforward and easy to check. NTC sensor, normal thermostat. We should have continuity on this thermostat. Turn your meter to continuity. We have continuity across the thermostat. Now we're going to check the NTC sensor. NTC sensors work on the principle that resistance will rise and fall, telling the program what is actually happening with the air temperature. Now I have a test lead for this. You can do it with a multimeter and you would need to set it onto ohms, but I will tell you it's quite difficult to get onto the pins while you're testing it. So I've actually got a special test lead which I plug onto the NTC sensor, connect up my meter. Right, I have the NTC sensor connected. It's slightly changed because I did touch it a few minutes ago, but basically the principle is, with the NTC sensor connected on ohms, we have a resistance. Now at the moment it's 2161 and it's slightly creeping up. What actually happens is if I put my hand down here and touch the thermostat or the NTC sensor, the resistance value will change. You can see the resistance value going down. Take my hand off, in a few minutes time it will start to rise again. But you can see all about how NTC sensors work at the website. Now we've checked the thermostat, we have checked the NTC sensor, we've checked the two thermostats on the heating unit, and we have also tested the heater itself. All of these are checking out and working perfectly. So I know from the process of elimination that we have a fault with the circuit board. Now I'll show you in-depth video at the website on how to check circuit boards completely, checking resistors, diodes and everything else. But now I'll quickly show you what the fault is with this machine and how to rectify it. Right, as you can see, we've got our meter here Slightly out because it's showing 0.08 amps being drawn, but that might be the instrumentation itself. Basically, when we turn it on, we should have the motor drawing roughly up to about an amp, and when the heater kicks in, if it was on low setting, it should be drawing somewhere in the region of 6-7, on high setting 8-9, maybe a little bit more. So I'll just turn the machine on to a dry cycle to show you this. Now you can actually see that the motor is drawing 0.84 amp, which is just under 1 amp. We have a voltage of 230 and we have no ampage being pulled on the heater. So basically you could do a test on the actual circuit board to make sure power is coming out. What we'll do is take the circuit board off and we'll have a look at the circuit board, because I suspect a relay has gone faulty. Right, again, to make sure you unplug the appliance after testing. Right, these are the 3 wires that go to the heater. You can check your voltage output on these. This is the heater relay on this circuit board. It does vary from appliance to appliance, but this is what I suspect is at fault, and we'll take this out and replace it, and I'll also show you how to test the relay. To actually test the relay, we need to take the relay off the board, and what we'll do is energize the relay with the voltage that's required. This will open the gate. If it's reading good, we should have continuity going across the gate. If not, it will stay open circuit although it's been energized. So first thing we have to do is take the circuit board off. So that means disconnecting the wiring. As I said earlier, make sure you take photographs of where the wiring came from. And if you look closely around the board, you normally find some little plastic lugs that you need to press down to release the board from the facial panel. It does vary from machines to machines, and there's also pins that lock it in place. So we have 2 on the outside, and then the panel can rest there, and we have the circuit board. Now this is the relay we're going to look at. We also have some resistors and diodes around the board. One of the relays is for the alternation of the motor going from right to left. Another will be a start, I imagine, and this is the heater relay. Now this heater relay is 12 volt relay and it's rated at 16 amp. So we need to replace this, if it is faulty, with the correct relay. Right, now what we're going to do now is desolder the relay off the board. We've got the 3 relays and this is the one we're going to do. Now you can desolder using a vacuum stick, or you could desolder using some desolder wire, but we've actually got a desoldering station and this sucks the solder off the actual unit. Now with our power supply set at 12 volt, we're able to energize the relay. Listen closely. This is the relay opening and shutting. We will now attach our multimeter to either side of the relay switching gear. and we will test the right hand side and the left hand side. This is a good relay, so we should have continuity. Now we'll test the other side. Again, good continuity. Now we'll swap over and use the old relay to show you as a comparison. You will hear the relay is going to be slightly quieter. Now you will notice when we connect up the meter now to the old relay, we don't get continuity across the contacts. Now once I've shown you this, I'm going to actually cut the relay apart to show you what's actually going on. The coil is energizing and throwing the points over inside the relay, but we're actually getting no continuity going across at all. And as I said, you can hear the relay is much quieter when it's clicking. Now I've got the relay apart and reconnected it up, and you can see the points, and when we energize, the points are thrown across. What has actually happened is the tips of the points have carbonized due to high ampage going through, and over a period of time the carbonization does not conduct electricity, but when forcing it, as you can see here, we get a little bit of continuity, but not a lot. And that's the problem with this relay switch. So what we need to do is resolder the new relay into the board. At the website you will find a load of relays that we have got listed for sale, but if you have a specific relay you're after, by all means send us an email and I'll send you a link to send us a picture of the relay that you have, and I'll try and match it up, as a lot of these machines are made all over the world and sometimes the relays are specific to the manufacturer. So we'll just solder this new relay in, and then we'll do a test on the machine with my test meter to show you the current and ampage being drawn when the heater is cut in. Now that we've put our new switch in, and we're just going to connect up the circuit board. So remember, you need to get it under these lugs, drop it down, make sure they both click into place. Now we'll reconnect the electrics. Right, now we've repaired the circuit board, I'll show you the difference quickly, and again we'll turn the machine on to exactly the same setting as last time, and we'll press start. The meter is still showing 0.7. Motor starts, and now it's kicking in the heat. We've got just under 9 amp total. And there you go. Thanks very much for watching this video. I hope it helped you, and I hope it helped you repair your tumble dryer. Thanks very much indeed for watching. Please remember to subscribe to the channel, and if we really helped you, you can always buy us a beer. Thanks very much indeed. Remember, at the website we have other videos showing you how to repair circuit boards on washing machines, cookers, tumble dryers and extractors. So please take a look at those, and please remember to subscribe to our channel, as that's what keeps us going and able to make these free videos for you. And for any parts you need, please contact us at the website. Thanks very much indeed for watching this video.